Good morning, children. So far, you studied about classification of elements. Today, we will study about periodicity in properties. The first point under this is atomic size. We know atomic size, top to bottom in a group, it goes on increasing. In a period when you move left to right, we all know very well, the size goes on decreasing. Top to bottom, why it increases? Perhaps again we all know that the number of shells goes on increasing. Left to right, when you move in a period, it decreases. Why? Because the effective force of attraction of the nucleus goes on increasing. How it is there? Suppose children, I have one thing, remember, what all trends we will study, what all properties we will study, they all will be for normal elements or representative elements, means all those which belong to S and P block. We have not taken into consideration in between your D and F blocks, not at all. Only S and P block elements, to which we call normal elements or representative elements, which you have been taught already. Now, suppose we had an element having atomic number 14. So it is 284 configuration. So suppose its outermost shell was having just 4 electrons, fine, 4 electrons. And it was having 14 protons. Now, whatever size was there is there, whatever force of attraction was there is there. Now the 5th electron comes in the same shell because they are of the same period. And in a period, the number of shell remains the same. So same third shell, 284, now the electron 5th has come. So for this 5th electron, as it was 14 electrons, children, it must be having 14 protons also because, an atom is a neutral particle. So for 14 electrons, they would have been 14 protons, and these were 4 electrons in the outermost shell. Once again, the period number defines or determines the number of outermost shell. So it is third shell, 4 electrons in this case, and 14 protons. Now, same shell, one more electron came, means now 5 electrons, there will be 15 protons. Now again, one more electron comes, so 6 electrons, so there will be 16 protons. Now children, same shell, and here, with the entry of each proton, or with the increase in number of protons, reason being, atom remains neutral. So this nucleus, with the increasing number of protons, becomes more and more stronger. And distance was, the same shell, the same. So what happens overall? Once this nucleus becomes strong, this will have a strong pull on this outermost shell, and it will get pulled towards this, and thus the size decreases. To which, in short, we say, since the effective force of attraction of the nucleus increases, atomic size decreases. Why effective force of attraction increases? Because with the entry of each electron, there's also one proton increasing in the nucleus, and nucleus becomes stronger. Hence, has greater force of attraction. That's why the size decreases. For which, the technical word we say is due to effective force of attraction of the nucleus, which increases, size decreases. Point clear, I hope. Now children, with this atomic size, we have one more term, atomic radius, to be studied. The size of atoms is normally expressed in terms of atomic radius. Now what is there, children? Here, what all values you see in the table, they are mainly of covalent radius. Now what is this covalent radius, children? I'm trying to show you here. Just try to understand what is this covalent radius. This is 1/2 of the distance between the centers of the nuclei of two similar atoms bonded together by a single covalent bond. I repeat, this is, suppose you have two similar atoms of any element and they are bonded together with the help of a single covalent bond. You take half of its distance, you call it covalent radius. I repeat, two atoms of the same element bonded together, normally same atom, otherwise if you know for atom A, the B can be calculated. So normally the atoms of same element bonded together with the help of covalent bond take half of that distance. Which distance? The distance between the nuclei of the two combining atoms. Take half of that, you call that covalent radius. They will not ask you what is covalent radius. You just need to understand the term. So what are radius values you see? They are actually of covalent radius. Now, what is van der Waals radius? You had two atoms of again the same element, but they were not combined together with the help of covalent bond. Right? Like here. They are not combined. But they are adjacent, they are the closest atoms possible at the distance. Means they are at their closest approach. The two atoms of any element when they are at their closest approach. Closest approach means they cannot come further closer without forming a bond. So they are at that closest approach when the bond is not formed, but at the same time they cannot further come closer. Take distance of the nuclei between the nuclei of those two atoms and half of that. Distance between the nuclei of those two atoms, half of that we call van der Waals radii. Now, children, you see, in covalent there is some sharing. They come closer, overlapping. So here the value, what actually should have been exactly the value of this particular atom, atomic radii, it is slightly lesser or lower than the expected value. And here it is higher than the expected value because this gap is also being measured here, right? This gap is being measured here. So what happens? Covalent is slightly lower than the actual value and van der Waals greater than the actual value. With the result, the difference between the two is quite high. With the result, the value of van der Waals radii for any element is much higher than its covalent radius. Okay? For any particular element or atom, the value of its van der Waals radii is always greater than covalent radii. Because here due to sharing, the value goes slightly down during measuring. And here, due to this gap, because the bonding is not formed, the value is higher than the expected. So difference between the two, this is lower than the expected, this is higher than the expected. So a good gap in between. So for any particular element or atom you see, the value of van der Waals radii is always greater than covalent radii. Now you will say, you are teaching us atomic size. Why have you come here? Now children, what all values you see in your table? When you will see your book at home, you will open the topic atomic size, atomic radius. The table will be there. This is your homework. You have to see what all points are taught here. At home, you will open the book and you will tick those points because you need to know these points are covered up and how much is to be done. Your book is for reference, but here we are teaching you all the essential points. Even if you note down, you pay attention here and note down all these points. It is your book. Required thing is everywhere. It will be in a copy. So, in the table which you see children, the size, atomic radius, left to right, you will find that it is going on decreasing, and for inert gases the value is slightly higher. So people get confused, are they big in size? No. Children, for every element we have the value in the table given there, the value of covalent radii. And since inert gases, they do not undergo bond formation, for them the values reported are actually the value of van der Waals radius, and they have to be higher. So apparently it seems that inerts are bigger in size, but the fact is, no, they are not. The size goes on decreasing. One fact. Second is, remember, children, the values reported for inert gases are even higher than your alkali metals. But remember, in a period, alkali metals are the largest in size. So no confusion. In a period, alkali are the largest in size and the size goes on decreasing. And children, there are many theories coming for inert gases. They even give a theory of electronic repulsions and all to prove the concept that the size is which you see in the table is higher. They try to give that theory also, but actually nothing of that sort, right? So simple, because for them the value reported is for van der Waals radii, and for other elements the value reported is covalent radii. Size simply goes on decreasing in a period, moving left to right. Alkalis are the largest and it just goes on decreasing. And once again, what all trends we are studying or we will be studying, they hold good only for normal elements or representative elements, or say for elements of S and P block only. Now children, in the evening are going again at home, you start these videos, watch these videos, and from these videos what all points I have told you, I have discussed with you, this is take it as my dictation for the notes. Note down those points. There you have explanation as well as the point. So what you can do is you note down those points because there will be notes. Otherwise children, this fat book, you cannot go line by line. You will never have that much of time, and it's not possible also to even cover up in 1 year if you go line by line. It will not be possible. So we teachers, we know what is to be covered up, what we have to do, what all points to be taken up. That's how we go. So we go a little selective. We will not leave any that point which you need to know, you should be taught. So what all is being taught is your syllabus, and you note down those points. Please write from day one. When ma'am was teaching, Rashmi ma'am was teaching, you must be having those points also, and please write from day one. Suppose you did not do for the last class, please do children, otherwise it will be very difficult from where to study, how much to study. So please go on noting down the points which I am giving you, right? Towards the end I give you a hint how to prepare. You don't have to write whole sentences, just the point. It's your copy. And once the chapter is over, you send it to your respective teachers. This is how you have to study at home. So here you pay attention, and then in the evening start your video again. Just half an hour video, not maximum, all during the entire class. Note down the points, keep your notes ready. Okay? So I hope the point is clear to you. I stop here. I will not repeat this point again, that you go on noting down. This is a permanent homework that every day what all has been taught, it has to go in your notebook. You have to note down the points. Is that clear? It's your understood permanent homework. Okay? Thank you children for this video.